Section 1.7, Exponents and Order of Operations. Okay, we're going to identify the base and exponent in an exponential expression, evaluate expressions with exponents, evaluate expressions with 1 and 0 as exponents, and use the order of operations to simplify expressions containing whole numbers. Okay, example 1, identifying the base and exponent. Okay, can just use the highlighter here. Okay, identify the base and exponent in each exponential expression. Okay, 6 is the base. Okay, it's your big number. Okay, and 2 up here is your exponent. Okay, 10 is the base and 4 is the exponent. Okay, it's going to be something you're just going to want to kind of just remember. Once again, the vocabulary of some of this stuff is going to sound kind of weird in the beginning, but we're going to get used to it. Okay, note, there is usually some confusion about the use of the word power. Since 2 to the 5th is read 2 to the 5th power, it is natural to think of 5 as the power. This is not true. A power is not an exponent. A power is the product indicated by a base raised to an exponent. Thus, for the equation 2 to the 5th power equals 32, think of the phrase 2 to the 5th power in its entirety. The corresponding power is the product, 32, okay? So just some notes about kind of being intentional with our words, okay? If you can learn anything in math, that's one of the things is just being very intentional. Okay, so 5 is not the power. The power is going to be the 32. What does it finally equal? Okay. So in order to illustrate exponential notation, we show several products written with repeated multiplication and the equivalent exponential expressions. With repeated multiplication, we get 7 times 7 equals to the 49. Well, 7 squared equals 49. So 7 squared is read 7 to the 2nd power, or 7 squared. Okay, here 3 squared is 9. Notice when you're doing this power here, okay, 3 to the power of 2 is 9. Well, that's just saying 3 times 3. So if I did 3 to the power of 7, well, that's going to be 3 times 3 times 3, 7 times. That's how powers work. That's how these exponents will be working. So let's do some examples here so we can kind of see what we're talking about. Okay, we got 6 to the power of 3, or you can say that as 6 cubed. Okay, so here we are going to have 6 cubed is equal to 6 times 6 times 6. Okay, well, what is that going to equal? And some of these are going to get large very, very quickly. So you can start doing the multiplication on this, but these are going to be some that you're probably going to want to get used to using your calculator. Some are going to be good to memorize, especially these cubes and squares. Okay, but when we do the math to this, we get 216. Okay, well, how about 5 squared? Well, 5 squared is the same thing as saying 5 times 5, and that is going to equal, 5 times 5 is going to be 25. Well, how about 2 to the power of 6? Okay, well, let's do 2 to the power of 6. Well, that's going to be the same thing as saying 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, and then one more. Well, 2 to the power of 6 is going to give us 64. Okay, let me double check that. Yes, 64. So you can see that exponential numbers, they get large very quickly. Okay, and that's good. Sometimes we need numbers to get large very quickly. Okay, let's come in here. Common error. Do not multiply the base times the exponent. Okay, 10 to the power of 2 does not mean 10 times 2. Okay, 10 to the power of 2 is 10 times 10. Okay, so look for that. Okay, if you got that little superscript up there, okay, that's what we're looking for. Definition. Any number raised to the first power is equal to itself. For example, 8 to the 1 is 8, or 6 to the 1 is 6, and 193 to the power of 1 is 193, which makes sense. If 8 squared is equal to 8 times 8, okay, well, 8 to the power of 1 is just 8 because there's nothing else being multiplied by it. Okay, continuing on. Okay, any non-zero number raised to the 0 power equals 1. For example, 2 to the 0 equals 1. 5 to the 0 equals 1. 46 to the 0 equals 1. The expression 0 to 0 is undefined. Okay, that is just going to be a trust me. Okay, for right now. Okay, and all these other ones I'll show you those later on, maybe in class. But just when you see that power of 0 there, make sure you just equal 1. So note, to help understanding the exponent 0, note that the pattern in the following order powers with the base. 3 squared is 9, 3 1 is 3, and 3 0 is 1. So that's why you get the power of 1 there. Okay, each value is the previous value divided by 3. In this way, defining 3 to 0 equals 1 makes sense. Okay, so let's do some examples here. Evaluate each exponential expression. We've got 9 to the power of 1. Well, what is 9 to the power of 1? Remember, that is just itself. So 9 to the power of 1 is just 9. Well, remember, 8 to the 0, right here, 8 to the power of 0, is like saying 8 divided by 8, which is just going to be 1. Okay? And then here we've got 15 to the power of 0. Well, same thing. That's just going to be, once again, to the power of 1. Doesn't matter what it is. Okay? And then 10 to the power of 1. Okay? Well, that's just going to equal itself. Okay? Remember, that's like saying times 10. Well, 10 times what? That's just it. 10. Okay, rules for orders of operation. Okay, let's go through these, and then I'll give you kind of a little anagram or whatever they call it to kind of remember this. Okay, we're going to simplify within groupings. Symbols such as parentheses, brackets, or braces. If there are more than one pair of grouping symbols, start with the innermost grouping symbols. Okay, that'd be like saying, say I had a bracket, but then inside that bracket I had a parenthesis, and then out here some numbers, and then out here some numbers, and in here some numbers. You're going to start here first. Okay. Evaluate any exponential expressions, something of the form like, say, 3 squared. Get rid of that first. Number 3 is very important. Okay. Moving from left to right, perform any multiplication or division in the order in which it appears. Okay. These next two you really want to pay attention to, because there is so much contention and anger over social media whenever something like this happens, whenever you see those funny little math little videos. Okay, once again, moving from left to right, perform any addition or subtraction in the order in which it appears. Okay, continuing on, note that in rule 3, neither multiplication nor division has priority over the other. Okay, whichever of these operations occurs first, moving left to right is done first. In Rule 2, addition and subtraction are handled in the same way. Unless they occur within grouping symbols, addition and subtraction are the last operations performed. Okay, now we can kind of think of all of this. Okay, here's the little thing I'm going to give it to you. We use the term, get my pen out here. Hold on one second. PEMDAS, okay, which stands parenthesis, exponent, multiplication, division, addition, subtraction. So if we kind of think of that every single time, you know what order you're going. Are there parentheses? Okay, are there exponents? Check for those. Is there multiplication? Check. Division, addition, subtraction. But remember, these right here, okay, left to right, left to right. Okay, so looking at our first one, and I kept all these, I'm just doing one example, we'll do more examples later on, but notice, going with PEMDAS, let's think of this again. Okay, are there any parentheses up here? Well, no, there's not. So I can come in here and go, okay, there's no parentheses. Are there exponents? Do I see any powers other than 1? Which basically, remember, when you don't see anything, it's basically a power 1. Well, I don't see that. Okay, well, how about multiplication? Oh, well, look, coming through here, multiplication and division, we have to think of those as the same thing. Well, notice here, I've got division, okay, as it says right here. So since division is happening first, I'm going to do that first. Okay, so 14 divided by 7 is going to give me 2. Keep the plus, and then notice I have some multiplication happening. Okay, so here I did the division first, and then I did the multiplication. Okay, so I multiply those together. Now I've got 2 plus 6 minus 5. Okay, well, I've got done with the multiplication and division. Now I can start, what's the first thing I hit? Well, the first thing I'm hitting right here is the addition. So my addition will be the third thing I do, and then my subtraction will be the fourth thing I do. And notice I'm just simplifying as I go along, okay? And when I get to the very end, I get 3 for an answer, okay? That's what I do this whole thing, okay? I do this the whole way through. So let's do one more example here. Once again, I'm going to write my PEMDAS, just so I don't forget it. Okay, looking here, notice I have a parenthesis here. So I do have a parenthesis that I need to take care of first. So that guy's going to go right there. Okay, so that's going to be my 1. And it says right here, operate the parentheses. Well, notice that what happens there after I get done with that, okay, and I get rid of the parentheses, I'm left with this part here. Well, now, looking over my PEMDAS, I don't have any more parentheses. I do have this little parenthesis here, but look, it's already been simplified. That is going to be multiplication now, which I'm not there yet. So let's look and notice that my step 2 is going to be exponents, because I got this guy right there who I need to evaluate, okay, which is just going to be 2 times 2 times 2, which creates this 8. Well, once I'm done here and I'm done here, well, let's start going in order here. What's the first thing I hit? Because remember, here and here, we treat those as left to right and left to right. So what's the first thing I'm hitting? I'm hitting this division first, okay? So the third thing I'm going to look at is going to be the division. And I'll go ahead and take care of the division. I got 30 divided by 10, which is going to give me the 3. And then notice right after that, I've got some multiplication happening, so I can go ahead and take care of that as well. Well, this is going to be 3 times 8. I have a plus. I can't take care of that yet. But then I've also got this multiplication happening here. So my multiplication is going to be my 4th step. And then for my final step, I've got this addition here. Okay, and notice there is not any subtraction anywhere in the problem. And once I do that, I get everything all kind of simplified out, and I get the final answer of 36. And that takes care of everything on the PEMDAS, going in order, taking care of the parentheses first, and then just working out from there. And that's exactly how we're going to do it. Now notice, I could have put all this inside a parenthesis and had other stuff going on, and I still would have got to the 36 on the inside before taking care of everything else. We just go in order, working inside, out, and making things more simple.